I don't know.
We'll find out in break.
Okay, so we left off yesterday. We talked a little bit about hollow parts when we're doing hollow parts. I mean, I don't think I have. No, I don't have a slide for hollow parts, so I just have to go back and tell you what I had said about that was that if we do have a hollow part, we're going to put it on what's called a central conductor. They call it central conductor. You can just call it a big bar if you want. So we have those copper bars. So, all right. So things that I would put on a central conductor. If I had any sort of hollow tube. So what kind of hollow tube can you think of that I would be doing like in an engine shop? You ever who said connecting rod? Have you seen a connecting rod? Are they a hollow tube?
No, but then you put one through.
Let's talk about hollow tubes.
I would think of like a cylinder barrel.
Okay, cylinder barrel would be a great example, except the head is screwed on and they don't come off. But, okay, if I was manufacturing them or had a facility that did unscrew them, which some do, that's a perfect example. I couldn't think of one. I was hoping somebody would. That's actually a perfect example right there. So if I didn't do that, I wouldn't see the inside where it's likely to crack. Okay, but things that I do put on a central conductor. What? Okay, so things I do put on a central conductor. We're talking about, I was looking for something, a hollow cylinder. Okay, now we can go into what I will do. So what did you say? Rocker? Oh, they are cylindrical. Yep, I did put those on. Okay, forgot about that. Gears, I'll put them on a central conductor too. Conrods, you said conrods? Yeah, I'll put the small end on a central conductor. No, I don't. NDT pushrod tubes. Don't. New ones are plastic. Old ones are. I just don't. You can just look at them. They're not a structural part. What was the other thing? Rocker arms. Rocker arms. Piston pins. Piston pins. I can put them on there. So I would do all of that. All right. Let's talk about two methods of media application. Two. Yeah. Oh, wow. That's just going great. Two with the W. Two methods of media. What is the media I'm talking about? Who said walnut? MJ?
Wasn't me this time.
Oh, God bless you for trying though.
Wet and dry.
Metallic plates.
Wet and dry. Wet.
No, Christian said
Wet. Okay, so the media is either the magnaflux or the magnetic particle fluid, the wet, or the dry. So we have the wet. So two methods of putting that media on. So one method would be wet continuous. And in order for it to be wet continuous, I must be using what sort of media? Wet media? not the dry powder? Okay, so wet continuous. So this, and how is it applied?
continuously.
Okay, well, sort of. Now, when I say that, some people think you're just constantly flowing it. Well, that's not true. So the media is applied while the magnetism is on. Is applied while the current is on. Sort of. My favorite word is sort of. Sort of changes everything. Kind of like, I love you, sort of. The kids are okay, sort of. Okay. What you cannot do, well, let me tell you what you want to do. What you want to achieve is you want to achieve a very wet part that is so wet and so saturated with the media that it's actually flowing and dripping off the bottom at the point where you hit the current. You do not want the nozzle on, though, because if the nozzle is on, you could be washing away an indication. Now, when we're doing crankshafts, we've done a lot of crankshafts in here because we just were fortunate enough to get a lot, which I think is really cool. Crankshafts, I want to say, are a little more forgiving than a lot of other things. So why would I say they're more forgiving?
Because it's hard metal.
Because it's hard metal, which means that
More residual.
residual magnetism works great in these things. Absolutely great. So you can put your fingers all over them. You can mess it up. You can kind of wipe it, put some more fluid on. Chances are it's going to work fine. right? I've never had too many problems where it didn't. Although when I get into really serious indications and a lot of examination, I see something that bothers me, and I want to wipe it off and it doesn't come back. Okay, if I wipe it, it doesn't come back, and it doesn't make sense why it doesn't come back, it's go right back in. I'm going to do wet continuous on it. So every time. But a lot of times I'll wipe something, put a little fluid on, it comes back. I know it's going to come back wet continuous as well, right? So I don't have to add that step. But so you don't want to be washing it off. If you've got a part that doesn't have high retentivity, which is your softer metals and stuff, you can actually just wash an indication right away. So you want it flowing, dripping wet, but not the nozzle on. So it's applied while the current is on, but not while the nozzle is on. I could put that, but not while the nozzle is on. I was making that up. All right. And then there is a risk of washing away indications if not careful. And by that, I mean media flow.
It should be washing away.
There is a risk of washing, away. Thank you. Indications if not careful. Media flow. Use less words, save time. Go SeaWorld. You guys know where that's from, right? It's Office.
You're too young.
I'll have to play that at a break. All right, so flow of media must be stopped. Must be stopped
You should put it on the test and Steve will know.
just before current is applied. Okay, current. How long is the current held on for?
Half a second.
Okay. Current is applied for 2 1/2 second bursts. Now our new machine, there are settings where I could go in and change either how many, it'll give 1 or 2. It'll automatically do 2, which it seems like Dennis prefers that to be on. Since you went and changed the settings on me, which is fine.
You did that too?
Yeah.
So
You changed it back when I did it.
I know, but
It was convenient.
it seems how you guys like it. Makes sense, so let's leave it on. All right, and I could change the timing on it. The machine I had at work, I could push the button and hold it for a very long time until the machine started to melt. So
Wow. You know that from experience.
no, well, I know from
Someone lean
experience.
against the wall.
Yes, I do, because people come in and lean against the bar, and I could hear it. Nah, like, and Ivan, you won't get shocked, will you? Nope.
I was surprised, but
he grabbed onto that thing and leaned into it, and it just went.
Oh, yeah. That's awesome.
Yeah,
It's small
Yeah,
voltage,
that's
right?
right.
Bit of,
Very small.
very small voltage. Yeah,
a lot of it.
I don't know how much voltage it is actually. We should measure that. We should do some
What is the
experimenting.
plug?
Huh?
Or is it hardwired? Is it hardwired in, or is there a plug?
Oh no, it's big wires. Have you not seen the wires coming into that thing? They're
Is it double-
gigantic.
Is it all double lock?
I'm not even sure. It's pretty big stuff. Although I shouldn't say that because the stuff running across and into the box is not that big, so it's not double aught. It's like 8, something like that. I don't know.
That's not very big.
Okay, but there's a lot of step ups going on. Or sorry, step down. So it's stepping down the voltage and up the amps big time. All right, so we have wet continuous. What's my second version here?
Right.
You know what? Why was it wet continuous? I should just not say. I should just do.
You do wet
Um,
You have
I could just get rid of wet and say continuous.
residual.
I gotta be careful with that because if I'm using dry, so
It's getting dry continuous.
I don't want to confuse you. Then it's dry continuous. All right, so I could say wet or dry continuous. But then I have to change some of this. I'll talk about that a little bit. So maybe I should say,
Why don't you just leave it the way it is?
I know, because I'm going to cover it. Let me see the media application. Wet. There we go. Yeah, because we've really only talked about wet stuff. So we can just say, oh, here we're talking about 2 methods of media application. I'm going to put this for wet. There, we'll do that. Then I'll come back to dry. Everybody happy about that?
Sure.
All right. Christian, you happy?
Yes, I'm writing in pen.
Okay.
Did you already cross it out?
No.
Change it to or?
All right.
I'll go into the
So we have wet continuous, and then
Really go pay for
it's just residual. They don't call it wet residual. It's just residual.
Greta would be so happy.
Residual. All right, and that is obviously where the media is applied after magnetism is stopped. After magnetism has stopped. Hey, by the way, I pulled up Continental's. They took all their service bulletins and a bunch of information and put it in a manual called the M-O manual. I don't love it. I'm more of a fan of the old style of the service bulletins because I can remember, hey, it was service bulletin like 74-16 is this, and go to that. Now it's like, oh man, what section did I do? But anyway, so I pulled up that and I did do, because I got an update to it. And so I looked up the requirements now for NDT, and they want you to use DC. It said wet continuous DC on almost everything. Let's see.
So they want to pick up.
So, yeah. Okay.
Would that be
So,
because they're
so
parts
people
of-
say that, and and be honest, I'm just almost repeating what has been said to me all this time. Oh, well, AC is great for surface, and DC is really subsurface. But I've always maintained that. Why do why would you say that? I've got a Ketos ring. I can see that it's giving me surface indications. I have no problems getting surface indications. So why do the skin effect? I know the skin effect causes it, but still with a good DC, I can see it just as fine. It's not like I'm missing out. So I don't know. All right, and it does not work. Does not work for parts with what? Low retentivity. How will you know if a part has low or high retentivity? How?
Magnetize it and check it with the Gauss meter.
Okay,
It'd be low, it'd be low.
that's your time.
Right?
What if I'm doing circular magnetization?
Circular magnet.
I'm just
Yeah, headshot.
talking out loud here. That's a headshot.
Yeah, so you wouldn't even see anything.
So you may not see anything. So how do you know?
Magic.
Magic. Well, I guess you could switch to a coil shot and find out, right? Yeah, okay. It's a little easier to measure that way. The way I did it was based upon what's its intended purpose. So that's one way to do it. And also, once you know, and a lot of getting your different levels is manufacturing. You have to know a lot about manufacturing, how flaws are made. I mean, man, there's some stuff that I haven't even heard of. Got a cold shunt. Oh, of course, a cold shunt's moving in. That's not what we mean. Oh, okay. But there's some parts that you know the manufacturing process. So, like for example, a crankshaft. I know that if a crankshaft is ground undersized, because you can do that. You can take a Continental, will go from 0 to 10. Lycoming goes 0, 3, 6, 10. So if you grind a crankshaft undersize, you can't just throw it back in service. It has to be nitrided. And nitriding is a process that hardens steel. It's put in ammonia. We'll talk about that next semester. In fact, all kinds. I often get a phone call. Hey, lost your crankshaft in nitriding. Well, how big is your nitriding room? I mean, just go in there and look for it. I mean, you haven't. That's not what we mean. It means it got destroyed in nitriding. Well, how did you destroy it? And then once I understood what nitriding is, I'm like, oh yeah, I can see how that would happen. We'll talk about that. But if something's nitrided, that's hardened. Okay, so what's hardened? Crankshaft, that's nitrided. Parts of a camshaft, nitrided. Gears, nitrided. So you just get to know. Rocker arms,
Nitrided.
only parts of them.
Only the tips.
Yeah, only the tips. Yeah, just connecting rods, No. Yeah, how do I learn that? Through experience. You see them all twisted and banged up and they didn't crack. Wow, that thing must not be nitrided. Also, another giveaway is anything that has any copper, residual copper on it. So if you see something that parts that tend to have a copper coating, you know the copper coating is blocking the nitriding process. So camshafts always had copper coating. Some of you guys are now seeing copper coating on some of your crankshafts. Camshafts have copper coating. Sometimes you see it on crankshafts. So anyway, you just get to pick that kind of stuff up. But when in doubt, what should you do?
Treat it as it is, not treated.
No. Continuous or residual?
Oh, continuous.
Continuous. In fact, there's never a time where I'm going to look at a part and go, residual it. It's good enough. I want wet continuous on everything. You guys see me, we're doing crankshafts. What is my big thing when you start off with?
Douse it.
Get it wet, come on, and you've got to wet everything because if you leave dry spots and it doesn't flow with the dry spots. And so, only time I really do residuals just on a crankshaft or something when I'm just checking an indication, something like that. All right, demagnetizing.
On the residual, is it the same media?
Yeah, this is wet. I'm talking wet here.
Okay.
So we'll get into dry in a little bit. So still talking wet. Got a lot of notes here about demagnetizing. Kind of want to condense this maybe a little bit.
Push the button.
Okay, so something interesting I learned today about pushing the button. Was that Josh? You were in there with
I
me?
mean, what I told you yesterday, it won't let you release the pedal until it.
Yeah, okay, no, there was that. I realized that you can't release the pedal. The machine will lock out the pedal. Love this machine. Will lock out the pedal. My machine at work would not lock out the pedal. You could step on it any moment and drop it right on the bed. In fact, I told you, people would walk in, step on the thing, drop something onto that. Those are hardened steel beds in there. They'll damage anything. And then lean against the bar. This one will not let you step on the pedal if it's in the middle of a process. Okay, there's that. Who was with me? And I said, why do you keep demagnetizing? Anyway, our machine automatically goes to AC when you hit the demag. So I put it on DC because I use DC.
I saw this one time.
Yeah, I use DC to magnetize something. DC has a lot more power on this machine. And so I hit the demag button and I watched it go right up to AC, light up AC, and it went. Now that was really interesting. You cannot, I tried it both coil and headshot. Our machine will not demagnetize in the DC mode, right? But it makes sense to me, and I'm gonna tell you why. So some things. So this is really something. This is more of a meism here. Part should, didn't say has to, should be demagnetized after each, I'm going to say shot. And then I wrote if required. Well, that just kind of, so what I mean by shot. So it was just my way of doing things, just like I always put the flange to the left, and it's just the way I did things. It's not right or wrong. But I would always do my headshots first, just because of what I did. So I'd do the headshot first. Then, when I went back up to do my coil shot, I would always demagnetize what I just did. And the reason why, you don't have to, right? And I'll write this, you don't have to. As long as my coil overpowered what I just did, it's going to realign the domains in the part. Then I have no problem. But what if I didn't get quite as much current out of my coil as I did in my headshot? Then it's not going to override that, and I will get a vectoring current. And I don't want that. I want a nice, clean, crisp change in direction. So I want it 90 degrees, or I want it flowing with the current. I want the longitudinal when I use the heads, and bam, I want it perpendicular when I use the coil. And I want to make sure I got that. So I did that. And it's not, to me, any extra work to demagnetize something. It's just one extra step. I want to do the best job that I possibly can. So I hit the demag switch. No harm in doing that I could ever tell.
How did it work on your machine?
Honestly, I really miss my old machine. I almost like it better than our new one, just because it was cool. It was a really cool machine. It was bigger. But it had, I told you guys, had the big clock face. It's about this big around. And so when and it was only AC though, so I would put it in the headstock. If I had it on 2, which was near the highest. 1 was the highest. If I had it on 2, I would put it to 1 step higher, hit the demag button, and it would clunk, 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 and it would give it a half second shot, go all the way around the dial down to 30, and it would be demagnetized.
That
So
took a long time then.
it took about just a little bit longer than this one, because there was the mechanical change. So you had to add that time in, but then half second. This machine, if you guys watch the lights, when you hit the demag, you stop hearing the machine, but the light is still illuminated. It's still going through its cycle. It's just really low. In fact, even on my old machine, you would get to the point where the ammeter wouldn't even move. It went up to like 30 was the highest number. And in the higher 20s, the ammeter wouldn't even budge. You would just barely see it flicker a little bit. So it wasn't even registering, but it still go through all of that. In fact, I didn't magnetize anything down in those numbers. It was just demagnetizing. So I say demagnetize after each one. So Y is failure. Failure to demag. I'm just going to put demag. Abbreviate. After, I'll say headshot. It works either way. You can go headshot, then coil. It doesn't matter. Can lead to a vectoring. And who is vector?
Oh, from. What is that?
Despicable Me?
Yeah.
Committing crime with both.
Magnitude.
What?
Directional magnitude, or what? I don't remember.
Direction and magnitude. I don't know if we really stopped and thought a lot about it, and we go back to our pi gauge. Yeah, it looked like there was one more piece of pie in there. If we did a headshot, of course, we should get this. And then if we did a coil shot, we should get this. And so if I did it wrong and I vectored it by 45 degrees, we'll just rotate it this way, 45, it's going to look like that. So, maybe I'm being just a little bit too picky about stuff, but that's why I love aviation, because when you're really picky about stuff, people consider you good, and usually aren't questioned. You seem a little picky to be working on an aircraft. Nobody says that. All right. So subnote under all that what I just wrote. It's certainly what I'm saying is not true. I'll just leave it not true. No, not true if applied magnetism is significantly. I don't remember if significantly is my word or a word out of the book. Greater than previous magnetism. All right, but how, let me see, 2 ways to demagnetize. 2 ways. And I'm sure there's more than 2. 2 ways to demagnetize. All right, so we can have decreasing current. Decreasing current. Okay, just want to make sure I can make it this right. AC or DC. But they're going to do it a little bit differently with each one. I want to make sure I got that in. So I've got this. Some machines have a step down demagnetizing function. Can you think of a machine that has a step down demagnetizing function? Our machine. Our machine has that. It just does it a little more electronically, so you don't notice the distinct changes. and is one continuous burst that slowly diminishes, rather than specifically at 1, then 2, then 3, then 4, or our machine, which goes the other way around. 1 is low, so 1, 1.5, 2, 2.5. So instead of doing, actually no, 10 is high. 10 is high to the, this one's completely backwards in mine. All the way left 1 is the lowest on ours. All the way left 1 on mine was the highest.
Isn't that how you were demagnetizing with the yoke on AC?
I'm going to talk about yoke a little bit, but yes, it was actually. So I used this method on AC. All right, so some machines have the step down demag. I don't think the one we got rid of, the red one that was here, had this function. That's why there was, if you guys remember, there was a giant table about this size with a huge coil going over it. Okay, so it had a separate table. Well, it's still in the hanger somewhere. We just don't need it. All right. Okay, I don't need to write this one though. So the principle is that the machine will automatically apply the next level down in magnetism until the part is magnetized at the lowest level. Unless you want me to write that. I can write that. All right. Oh, gosh. Okay. The principle is that the machine, why you make me write it? You can't read it, I write anyway. Will automatically apply the next lowest level of magnetism. Next lowest level of magnetism. And when I wrote this, I was thinking more of the machine that I used that was definitively a next step down. 1, then 2, then 3, then 4, then 5, all the way through, going to the highest number, which was the lowest amount of current. All right, magnetism until the part is magnetized at the lowest level. Now, note that I didn't write until the part is demagnetized. Is it demagnetized? Nope. It's magnetized to the lowest level. So what it's doing is it's following that hysteresis curve that I showed you. You're gonna what? This right here? All right. So it's following this. So it's magnetized here, then here, then here, then here, then here, then here, then here, and here, here. Until it gets down to here, it's like, okay, we're just magnetized right about there, which is really close to the 0 point, but not quite. It's just offset from the 0 point, but it's still got magnetism. So you cannot, you can demagnetize something. There's only one way to really demagnetize something, really. So when we say demagnetize, what we're really saying is magnetize or remove the magnetism to an acceptable level. Next lowest level. Okay, so our machine automatically goes to AC. The machine I had just only had AC. The big coil that I talk about is AC. You can demagnetize with DC, but not only does it have to diminish, it has to reverse. So I think that's why our machine doesn't, because it would be too much money to actually make it go plus, minus, plus, minus, plus, minus, plus, minus, plus. So if you're going to demagnetize, we'll talk about a yoke, you literally have to go back and forth, and diminish, and that's more of a pain in the butt than it's worth. All right, so in DC, magnetism is reversed. Each time. So every time you would hit the button, it would have to reverse. So let's say you wanted to use our machine to manually demagnetize something. So what you would do is you would put it in the coil. So hold it in the coil, hit the demag switch. Then turn it down, take the part out, turn it around the other way, put it back in, hit the switch again. Then turn it down a little bit, reverse it, put it in. Turn around, reverse it, put it in. All right, so.
Pay by the hour, that's all right.
Yeah, well.
Good thing
You're gonna
All
wear
right.
out the foot pedal.
We're at the bar? Oh, the foot pedal? Okay. And we just talked about this, so consider the hysteresis curve. Hysteresis curve and its effect. It is impossible to completely demagnetize something demagnetize a part unless, I bet you know the answer.
Throw it away.
No,
Very
I bet Prince knows the answer. This sounds like something that would be right out of your brain.
Superheated
Super chill.
or earth grounded.
No, they
Just time?
huh?
Just time?
Okay. I don't know if time would work. Unless it is, and what did you say, Prince?
Superheated.
Superheated. Heated to its Curie temp. I wonder if that was, it had to be Madame Curie. I bet that has something to do with her.
I like curry.
Curie temp. Which is simply 770 to 1390 degrees
I like curry too.
F. All right. And cool. And cool. In an east, west orientation. In fact, it is suggested that if you store aircraft parts for a long period of time, they should be faced east and west. Because if when you lay them north and south, you will pick up the magnetic lines of flux and it's more in line, it will induce magnetism in it. Just like lodestone. I believe it's actually true. It's lodestone. Think about what happens in nature. That's exactly what happens. I didn't write this.
What was that, Christian?
Okay, large AC coil. So we had the large AC coil. Now the way that worked, you guys over here got to use it, right? A little bit. It had a timer on it. It just had a timer, and funny, the timer went up very high, so the thing must have had a really high duty cycle. He said duty. So I had a high duty cycle. All right, but where's the diminish in it? It's just on. I could turn it on for 5 minutes. You know, by the way, it was really fun because in that room we had a tube type TV and it would really mess with it. So. Why was the tube type TV on? I don't know. So, okay, so where's my diminish? So I just put it in, turn it on, turn it off. What's that, Steve? Steve's got it? You got to move the part away. So you'd put it in the coil and you'd move it around in the coil. So I would take a part and I would actually put it in there and move it around and tumble it and kind of scramble it in the coil and move it around, and I'd pull it out at least a good 6 feet away from the coil. That's the diminish.
People
Because
watching you from the outside that have no idea what's going on.
I know why.
What the hell is this guy
Why is
doing?
this? Is this some sort of weird dance? What is this? You get that on Fortnite? I don't know. You know, so, all right, so
Dancing with the parts.
what's that?
Dancing with the parts.
Yeah. Now that's hard to do with a crankshaft, especially a 6-cylinder. You know, the best you could do, there's a table and you'd move it back and forth, back and forth, back and forth, grab it and just walk away. That was the best you can do. The machine that I had, because it wasn't electronic with a half-second time pulse, lay on the bar, push the button, and actually it was, the bar really just had a little thing that pushed a button in the middle. There was a button here and a button there, so it just really pushed on the button. The longer you lean into it, the longer it would stay on. It would stay on until you let up. So I would just roll the coil out, and I could demagnetize stuff right there while I was just holding the bar down, right there in my 12-inch coil. So I would just tumble it, pull it out, set it down at the other end of the bench, or set it on this side of my bench. So I could use that the same way. So it worked the same thing. So large AC coil. So you had to place the part in the coil, tumble, if possible, tumble and remove while coil is energized. What happens if you're one of these people that put it in the big coil, you turn on the timer, kind of move it around, scramble it, shut off the coil, and then pull it out? That's called AC magnetization. So it will magnetize it to whatever you just turn the machine off at. So if the machine was set at 500 amps, hey, guess what you just did? You just magnetized it. So it would magnetize too. Just put it in and give it a shot. It's the same thing. So if you turn it off while it's on there, it's just like a very long magnetizing push. So you've got to be able to move it out of there. All right, so we'll take a break and start talk about something different.